Kush, wherever we go. Visualize it. I'll give it something to do. Get a wildfire burning. Visualize it. I'll give it something to do. Ace high and going all in. Visualize it. Hey, what's up, everybody? Welcome to another wonderful day of math class. This is, after all, day 3, and you guys are chugging along. I'm pretty proud of you guys so far. So let's keep that momentum going. First thing I want to talk to you today about is the samurai sword. This is the strongest ancient medieval weapon. So before guns and tanks and stuff, this was the go-to thing. And the reason why it was so powerful was because it was folded in and on itself over 20,000 times, right? So what they would do is they'd take a thin sheet of metal and they'd stick it in the fire. And then when it got brittle enough or bendable enough, they would come and bend it over. They'd cool it, stick it back in the fire, and bend it again. And so what I want to show you guys is you guys all get out a piece of paper, like so, and do the same thing, right? Make a bend. Always be bending it in half, right? That's 1, that's 2, that's 3, 4, 5, 6. Every time you do it, it gets harder. I can't do 7. So what happens is that the paper gets folded in on itself. So while you start with just one sheet of paper, right? One thin plane, when you fold it in half, it becomes 2. And then when you fold that in half, it becomes 4. And when you fold that in half, it becomes 16. And when you fold that in half, it becomes, I don't know what 16 times 16 is. Let's do it real fast. 256. So, after just 1, 2, 3, 4, 5 times, 5 folds, you're already at 256. Mr. Carr made it one more, all the way up to some ungodly number. But the point is that every time it goes and gets bent on itself, it becomes stronger. And you are much the same. When you are put through adversity, you have 2 choices. You can either become stronger or you can break, right? And with this whole situation, you guys are being placed in this adverse situation. Nobody in the world has ever gone through this, and it's making you stronger. Or you're breaking, but don't worry. I'm here to make sure you don't break. So let's be strong samurai swords, and let's get after it this semester. So moving on to algebra review. This is an algebraic equation. It represents a line on a graph. So what we're going to learn today is how to plot and solve that graph as part of our review, right? So what I always like to do when I get an equation is I like to make an x and y table. This way I can plug in values for x and see what my y value is. So when I plug in a value for x, I want to pick something easy. I don't want to pick like 0.62875 because that's a lot of numbers and I'm lazy and I'm already getting tired, right? So I'm going to pick easy numbers, like 0. When I plug in 0 for that, I get y equals 3 times 0 plus 1. Remember order of operations, we do 3 times 0 first, which is 0, and then plus 1 is 1. So our first point is 0, 1. Our next point, let's plug in a 1. That'll be easy enough. 1 for the x value. 3 times 1 is 3. 3 plus 1 is 4. Our second point is 4. 1, 4. Let's go ahead and do one more just for fun. Plug in a 2. 2 times 3 is 6. 6 plus 1 is 7. So now we have 3 points that are on our line, right? This equation, remember, represents a line. If you have 2 variables, it's going to be a line. So how do we plot that line? Let's go to our graph, and I brought the table with us. Our first point is 0, 1. So x is whether you go whether you go right or left, and y is whether you go up or down. So in this case, 0, 1, I go left or right 0 spaces, and then I go up 1 space. So my very first point should be right here. Let's make that a different color so you guys can see it. Very first point should be right here. That's 0, 1. I went left, right, 0, up 1. My next point is 1, 4. So I go 1 over and up 4. So my next point is right here. As soon as I have 2 points, I can draw a line, right? And I'm going to go ahead and do that because my point 2, 7 would be off the charts. So you see I connect the 2 points, extend the line, and I have graphed my equation. All right. What if the equation's a little bit complicated? So remember, back to our algebra, right? We have to do the same thing to each side, and we want to end with something that looks like a variable or a letter equals a number. So in this case, we want to end with y equals some number. I don't know what it is yet. We'll figure it out when we get there. The first thing I want to do is combine everything that I can. So in this case, I have 7 times 2/3. Those are 2 numbers, so I can just push them together by multiplying them together because that's what it tells me to do. To multiply fractions, we have to have 2 fractions, right? So I'm going to convert 7 into a fraction. It's real easy. It's just 7 ones, right? And then 2/3 is always already a fraction, so I don't need to do anything to it. And so we have 7 over 1 times 2 over 3. All we have to do is go straight across. 7 times 2 is 14. And 1 times 3 is 3. So our answer to 7 times 2/3 is 14/3. All right, going back to our original equation, we have 4y plus 3 equals 14/3. The first thing I want to do is get rid of this 3, right? I'm going to have to get rid of the 3 and the 4, but let's start with the 3. So I'm going to subtract 3 from both sides. The 3's over here cancel, and I get 4y equals, and then I want to convert -3 into thirds. So I would multiply by 3 to get -9/3.
Miss Wilson, if you're in the building, Miss Wilson, you have someone out there waiting for you. Thank you.
See, it's just like real school. You get interrupted by the announcements, just like always. So -9/3 is the same thing as -3. And 14/3 minus 9/3 would give us 5/3. 14/3 minus 9/3, 14 minus 9 is 5, and the thirds stay the same. So we're at 4y equals 5/3, and we have 1 step left. We have to divide by 4. What's really cool about dividing when you're already in a fraction is you're dividing and you're dividing again. So what you can do is you can just combine these 2 divisions, 3 and 4, to make it 12. So we would have y equals 5/12. Because it doesn't matter if you divide by 3 and then by 4, or if you divide by 3 and 4 together, which would be dividing by 12. All right, so our correct answer for this case is y equals 5/12. Very good. All right, now we need to talk about translations. So once again, remember, a translation is when I move an object left or right or up or down. So we're going to use my smiley face as an example here. And we can't use left and right and up and down because those aren't actually real, right? Left and right is based on you as a person, right? In a mirror, your left and right are different, right? Up and down is based on where you are on the globe, right? Somebody who's on the other side of the planet, in Asia, for instance, has a different up and down than us. Imagine you're in space. What is up? What is down? Who knows, right? So we have to use mathematical terms, right? So we pretend that the plane is a grid, and that if we move left or right, we're going to be moving in the x direction. So if I want to translate right, that is a positive x. So if I were saying translate positive x, right? How I would write this is I would write the translation in the x direction first. So if I wrote positive 4x, that would mean I would go over 1, 2, 3, 4. If I wanted to have a direction in the y direction, that is up or down. Up is positive and down is negative, just like right is positive and left is negative. So if I wanted to go down 4, 1, 2, 3, 4, that would be a translation of negative 4 in the y direction. So this translation of positive 4 or negative 4 would be 1, 2, 3, 4 right, and then 1, 2, 3, 4 down. So translations left and right, positive would be right and negative would be left, and you would do that first. Translations up or down would be positive up and negative down, and you would do that second. Just like in a point, this first value is your x value, and the second value is your y value. Sorry. It goes the same with translations. Your first value is going to be your x value, positive or negative, or 0 if there's no movement. And your second value would be your y value, positive for up, negative for down, 0 for it stays the same. Next up, we have rotations. Rotations have a direction and they have a degree. So there's two things to do. First, you have to imagine whether it's going in the direction of a clock or in the direction against the clock. Mr. Cartwright actually wrote 2 clockwises here. So I have to go the other direction. If I'm going this way, then I would be going this way, right? This way would be called clockwise because if you can see a clock, right, the hour hands are going to go in the direction of clockwise, right? And the other one is counterclockwise because it's going against the direction of a clock. So first you need to figure out which direction it's rotating. And technically you could do either direction, right? If you rotate this star over here all the way around, if you rotate the star all the way around, that could either be a clockwise rotation of 360 degrees or a counterclockwise rotation of 0 degrees, right? So if we move it 90 degrees, it would look like that. 180 would be another. And then you can rotate all the way back to your original starting point, and that's always going to be 360 degrees because that is a full circle. Once again, we will have to measure the degree of rotation by using a protractor. However, in most of your assignments, you can use a right edge because we don't have protractors for you. All right. So rotations, counterclockwise or clockwise, and how many degrees did you rotate it? And then for translations, you have to tell me how far you went left or right and how far you went up or down. And that would be represented left or right in the x direction, up or down is in the y direction. Okay, hopefully that all makes sense. And you guys have a wonderful day. Please return to the live classroom. Thank you.